Okay, let's go and quickly finish up problem 2, in which we started in the previous video. Okay, so what we've done so far was we've stated the null and alternative hypotheses, identified the claim and the problem, okay, which is in this case the null hypothesis. Okay, then we went ahead and used StatCrunch to get the critical values of the test. Okay, so we determined that this is a two-tailed test because the not equal to symbol is used in the alternative hypothesis. And we discussed that when you are asked for the critical values of a hypothesis test, okay, you want to know, right, whether it's left-tailed, right-tailed, or two-tailed. Okay, and that's going to depend on the symbol used in the alternative hypothesis. Okay, so once we found the critical values using the t-distribution calculator in StatCrunch, okay, so when you calculate or when you perform hypothesis tests on the difference between two means, or if you're doing a hypothesis test on one mean, okay, you're using the t-distribution, okay, the t-probability distribution, okay, so the critical values are based on the level of significance. So in the case of a two-tailed test, okay, we went to the stat menu, selected calculators, and then selected t. Okay, and then for a two-tailed test, you're going to select between, enter the degrees of freedom, as we discussed in the previous video, and then enter 1 minus that significance level. Okay, so for a two-tailed test, right, select between. For the relevant probability distribution, okay, enter the degrees of freedom if necessary, and then enter 1 minus the significance level, and then you'll get the two critical values. So for the t-distribution, and then for the normal distribution, okay, the critical values will be the same, but one's negative, one's positive. Okay, so the t-distribution and the normal distribution are both symmetric. Okay, but for other types of probability distributions where you are performing a two-tailed hypothesis test, okay, where the distribution is not symmetric, okay, the critical values will both be different. Okay, so in any case, once we have those critical values, we then calculated the test statistic, okay, using the appropriate function from the stat menu. Okay, so we went to stat, t-stats, and then two samples, since we're dealing with two samples, and since we had a summary of the two samples, we selected with summary and then entered the appropriate information. Okay, and our t-stat ended up being this. Okay, so then the next part of the question was, identify the rejection region. So this might not have been obvious how I determined what answer to select for the rejection region. So select the correct rejection region or regions below. Okay, so here's a graph of a t-distribution. So it's bell-shaped and symmetric. Okay, so t equals 0 is always in the middle. So this line here represents t equals 0. So here's the first critical value, and here's the second one. All right, so one's negative, one's positive. Okay, so because this is a two-tailed test, right, you have a rejection region in the left tail and a rejection region in the right tail. So you have two rejection regions for a two-tailed test. So if this were a left-tailed test, right, you only have a rejection region in the left tail. Likewise, if you had a right-tailed test, you would only see a rejection region in the right tail. Okay, so the rejection regions are shaded. Okay, so in other words, if your test statistic is less than this critical value, okay, or greater than this critical value, okay, you're going to reject the null hypothesis. So in this case, our test statistic is 2.152. Okay, so it's clearly greater than this critical value. So this test statistic goes in the right-hand tail, so somewhere right here. So it falls in the right tail. Okay, so it falls in the rejection region. Now, if your test statistic was between the two critical values, so if it was between negative 1.895 and 1.895, right, then you would not reject the null hypothesis. So it would not fall in the rejection region. Okay, but it does fall in the right tail of the rejection region. Okay, so in other words, how do we answer that question? Okay, if it were a left-tailed test, you would select this option. If it were a right-tailed, you select that option. Okay, So the rejection region will never be between the two critical values for a two-tailed test. Okay, so it would never be this option, right? So it would have to be this option, right? So it's either less than the negative critical value or greater than the positive critical value, right? Would be the rejection regions, okay, like I showed you. Well, we type in the test statistic, okay, and because the test statistic fell in the rejection region, okay, we reject the null hypothesis. So then this would be our conclusion. So there is sufficient evidence to reject the claim that the mean annual cost of food for cats and dogs are the same. Okay. Okay, so the claim was given in the null hypothesis. Okay, our test statistic told us to reject the null hypothesis. Okay, so there's sufficient evidence to reject the claim given in the problem. Okay, that the mean annual cost of food for cats and dogs are the same. Okay, that would be your conclusion, and then we select the appropriate answer to complete the problem. So in this case, we select your answer from the drop-down menu. Okay, likewise, you can select your answer here from the drop-down menu. Okay, so if you were asked for the p-value, right, you look at your result in StatCrunch. Okay, we see that the p-value was 0.0482. Okay, so our p-value was 0.0482. So the p-value of the test was 0.0482. Okay, so remember the p and p-value stand for probability. Okay, so that number there is a probability. Okay, p-value is always a probability. Okay, and it tells you the probability that if the null hypothesis is true, right, what are the chances you get a sample or samples like the one we got? Okay, so the chances are about a little more than 4%, close to 5%. Right? If you convert that into a percentage, that's about 4.8%. Okay, so if we assume that the null hypothesis is true, right, that there is no difference between the annual cost of food for cats and dogs, okay, the chances that we would see these types of results, okay, with our sample data, okay, is about 4.8%. Okay, so a fairly small chance. So remember, right, when we do the p-value approach in hypothesis testing, okay, we always compare the p-value to the significance level. Okay, so according to the problem, our significance level was 0.10. Okay, if our p-value was greater than or equal to 0.10, okay, if that probability value was greater than or equal to 0.10, right, we would fail to reject the null hypothesis. Okay, like we've always done. Okay, but because the p-value here is less than our significance level, all right, we reject the null hypothesis. Okay, so in other words, whether you use the critical value approach, okay, like we did here, to do the question, right, the critical value approach and then the p-value approach should always lead to the same conclusion. So since we rejected the null hypothesis with the critical value approach, okay, we would also reject the null hypothesis with the p-value approach. Okay, but the p-value approach is actually a lot easier than the critical value approach because you don't have to find the critical values from the relevant probability distribution. And you don't have to worry about the test statistic. Okay, you only need to worry about the test statistic, right, if the problem asks you to find the critical values. Okay, so again, before we conclude the video, right, since the p-value is less than our significance level of 0.10, okay, we reject that null hypothesis. Okay, so likewise, if you do the p-value approach and you reject the null hypothesis, that means that your test statistic is going to be in the rejection region of the relevant probability distribution. Okay, likewise, if you get a p-value that's greater than or equal to the significance level, right, that means your test statistic is not in the rejection region. Okay, but in any case, right, the two approaches, right, whether it's the critical value approach or the p-value approach, will always lead to the same conclusion. Thank you for watching.